Hey, this is Miss Pi. I'm doing a recording for the Systems of Equations test review. I'm going to go through this pretty quickly, so please pause the movie and rewind it if you need to. So let's look at the first couple problems. We have systems of equations, and we have a possible solution, and we just need to check and see if it is indeed a solution. So to do this, you're going to replace in this system here, you're going to replace all your x's with -2, and you'll replace your y values or your y variables with a 2. And you want to do it one formula at a time. So we'll start with the top one, and we just plug in -2 for x and 2 for y. Then you're going to simplify by multiplying these two 2's together to get 4. And then -2 plus 4 is going to be 2. And so 2 does equal 2, which is a true statement. You can't just stop there. You need to keep on going and plug in the -2 for x and 2 for y for the second equation, and you'll get this. And when you multiply the -2 times -2, you get 4, and 2 plus 4 does equal 6, so this is also a true statement. And because you got a true statement from both systems of equations, then -2 is a solution. Let's look at this system over here. This time we have 4 and -1. Again, you're plugging 4 and -1 for x and y, and then you're going to simplify. 5 times 4 is 20, -4 times -1 is +4, and you get 24 equals 20, which is a false statement. And then let's check our second equation. We have 3 and -1, or times -1, and that's supposed to equal 2 times 4 minus 1. When you simplify, you get -3 equals 8 minus 1. Simplify further, you get -3 equals 7. Again, that's also a false statement, so that means that 4 and -1 is not a solution to the system of equations. If you want to check your work, you can always graph the system of equations, and on the one on the left, you notice that they intersect at the coordinates of -2, 2, so you see that that is a solution. On the one on the right, notice 4, -1 is actually down here. Sorry about that, guys. 4, -1 is down here, but neither of the graphs actually cross 4, -1. All right, let's look at another set of problems. We have inequalities here, and we have a possible solution. Again, we're just plugging it into our solutions or our inequalities. So x is going to be 4, y is going to be 3. We plug that in, and we get 3 is greater than or equal to -4 plus 3. When you simplify that, you get 3 is greater than or equal to -1, which is a true statement. Let's check the next set of inequality. You get 2 times 3 is less than 4 plus 6. And when you simplify that further, you get 6 is less than or equal to 10, which is also true. And because it's true for both statements, that means that 4 and 3 is a solution to your system of inequalities here. Let's check the one on the right. Again, this time we're plugging in 1 for x and 1 for y to see if it's a solution. And that's what you get at the beginning. Then you have 2 minus 1 is less than or equal to 5. Simplify that further, and you get 1 is less than or equal to 5, which is a true statement. Now let's check the second equation. Plug in 1 for x, 1 for y, and you're going to simplify. You get 1 plus 2 is greater than 2, which is true because 3 is greater than 2. So that means that this 1, 1 is also a solution. And again, you can check this by graphing your two equations. Here's the two equations graphed, and you can see in the shaded section is where you see the coordinates of 4, 3. And the one on the right, graph the two equations. And again, in the section that is shaded by both formulas, you have the 1, 1 there. All right. Next one says solve the system by graphing. The most important thing to remember when you're graphing this is your formula needs to be in slope-intercept form. So your y needs to be on one side of the equation and everything else is on the other side. Now this set system here is already set up in slope-intercept form. So the first thing we're going to do is plot our y-intercepts. So our first y-intercept is at -1, and then our slope is +1. So here's our y-intercept at -1 with a +1 for a slope. That means we're going up 1, to the right 1, up 1, to the right 1, up 1, to the right 1. And then that's how we got this blue line. And then the next equation we had +1 and our slope is -1. So our y-intercept is at +1 with a -1 for the slope. That means we're going down 1 and to the right 1, down 1 and to the right 1, down 1 and to the right 1. And you can see that the two lines intersect at the coordinates of 1, 0. So this would be the graph, and the solution would be 1, 0, because that's where they intersect. Okay. This one, we have two situations where, again, we're trying to solve the system by graphing. And this time the system is not in slope-intercept form, so we have to put both equations in slope-intercept form. I'm going to show you guys how to do both of these equations at the same time, because if you notice, the top equation for both systems is exactly the same, and the bottom equations on the systems of equations, the only difference is this one is equal to 2 and this one is equal to -6. So when we're going through the process of putting it in slope-intercept form, a lot of the steps are going to be exactly the same. So let's look at the first equation. The first thing we want to do is to get -6y by itself. And so we're going to subtract 3x from both sides of the equation. Notice I did it on both sides. Okay, once I subtract 3x from both sides of the equation, I'm left with -6y is equal to -3x minus 9. In order to get rid of this -6, I have to divide both sides by -6. And when I do that, I get y equals the -3x divided by -6. The negatives cancel each other out, and the 3/6 reduces to 1/2, and then the -9/6. Again, the negatives cancel each other out, and -9/6 reduces to 3/2, and that's going to be the same for both sides. Okay, because we started out with exactly the same equation on both sides. Now for this bottom equations, again, remember the only difference is this one is equal to 2 and this one is equal to -6. And so on the left side of your equal sign, you're going to want to get rid of the 2x, so you subtract both sides by 2x. Okay, and you end up with -4y on the left, and on this side you get -2x plus 2 because we're left with it. We had a 2 over here. On this one we have -2x minus 6 because we had a -6 there. Now in both cases, to get rid of this -4 that you're multiplying your y by, you're going to have to divide by -4. Okay, so we're dividing by -4 here, we're dividing by -4 over here. Okay, and then for this equation, we end up with -2 divided by -4. The negatives cancel out, and 2 divided by 4 reduces to 1/2. And then over here we have a +2 divided by -4, and that reduces to -1/2 because you only have one negative sign here where you had two negative signs here. If you have two negative signs, it cancels out. One negative sign, it stays negative. All right, now for the equation over here, again, you're dividing by -4. Your slope is going to be 1/2 because the -2 divided by -4 reduces to 1/2. But this time, -6 divided by -4 reduces to +3/2. The negatives cancel each other out. And so for the left side, sorry about the background noise. Some of my kids are making noise. So the system over here on the left, you're going to graph this equation here, and you're going to graph this equation here. Those are the two equations that you want to graph in your calculator. Okay, and so when you do that, this is the picture that you get on your graphing screen, okay, or when you sketch it on your paper. Okay, on this side, you're going to graph this equation here and this equation here, and hopefully you notice before you start drawing anything on your paper, hopefully you notice that after you do all the simplifying up here and down here, you end up with exactly the same equations. Those are exactly the same. So when you graph them, you're going to have a situation that looks like this, okay, where the lines are right on top of each other. So when you have graphs where you have parallel lines that never intersect, you have no solution. When you have graphs where the lines are right on top of each other, you have an infinite many solutions. Okay. All right, now the next set of problems on your review packet, it says to solve the linear system by either doing elimination method or substitution method. I have specifically chosen the easiest method for each one of these types of problems. Okay, so for the first two systems of equations, notice you have a negative y here and a positive y here. The easiest method would be to do the process of elimination. And even though here you have both positive y values, all you have to do is multiply everything in this equation by -1, and then you have a negative y value, and you can still, the elimination method is still the easiest method. All right, so let's look at this side first. So we are just going to, because we have two different signs here, we're just going to add the two equations together. 3x plus 2x is 5x. Negative y plus y is 0. And then 9 plus 1 is 10. And then when you reduce that, you end up with 5x is equal to 10. And to get rid of the 5 that you're multiplying x by, you're just going to divide both sides by 5. And that simplifies to x equaling 2. Okay, once you know that x is equal to 2, you can pick either one of these equations to plug in a 2 for your x value, and you're just going to solve for your y. I chose to do the second equation, but it would have worked with the first equation as well. So I plug in 2 for x, I get 2 times 2 plus y equals 1. 2 times 2 reduces to 4, or it multiplies to get 4, and then I want to divide 4, excuse me, not divide, I want to subtract 4 from each side of the equation. And when I do that, I'm left with y is equal to -3. So for this system, my x is going to equal 2, and my y is going to equal -3, and you would set it up as a coordinate point. Here's your x value and your y value. All right, now let's look at this one, solving this linear system by the elimination method. Again, remember I said you had to multiply your second function by -1. And then when you do 3x minus 2x, you get 1x. And remember this -1 distributes here to the y and to the 0. So y minus y is 0. And then -4 minus 0 is just -4. And so you end up with x equaling -4. Now that we know that x is equal to -4, we can plug in the -4 for x into either of the equations. This time I chose the top equation. And once I simplify that, I get -12 plus y equals -4. So I want y to be by itself, so I'm going to add 12 to both sides of the equation. And when I do that, I get y is equal to 8. So I now know that x is going to be -4, and my y is going to equal 8. So my system of equations is -4, 8. All right, let's move on to the next two problems. This time I'm going to use my substitution method, and the reason why I chose substitution is because in both cases I have one of my equations is solved for one of my variables. So here I have x is equal to y minus 3. Here I have x is equal to -3 plus 4y. In both those, I'm going to substitute what my x variable equals into the other equation for x, okay? And I'm going to solve for y. Let me see if I can do that without moving everything. Oh well. For some reason, these ones are acting kind of funny. Pretend you don't see all this. All right, so I took the y minus 3 and I plugged it right in here for x, so that you see that right here. Then I have to distribute the 4 throughout the parentheses, so I get 4y minus 12 plus 3y is equal to negative 5. I'm going to combine like terms. This 4y here plus the 3y becomes 7y, and then I want to get rid of this negative 12. I'm just going to add 12 to both sides of the equation, and when I do that, I get 7y is equal to 7, because negative 5 plus 12 is 7. I'm going to divide both sides by 7, which tells me that y is equal to 1. Now that I know that y is equal to 1, I'm going to plug in a 1 for this y up here so I can solve for x. And when I do that, I can simplify that, and I get x is equal to negative 2. So I know that this system of equations, the solution to this system of equations is negative 2 for x and 1 for my y value. All right, let's look at this one again. I'm going to replace this x with negative 3 plus 4y, and it looks like this. Now I need to distribute the negative 3 throughout the parentheses, and I get 9. So negative 3 times negative 3 is positive 9, and negative 3 times 4y is negative 12y. And then I still have the plus 5y out here is equal to 2. I can combine like terms. Again, I'm going to combine like terms, and negative 12y plus 5y is going to be negative 7y. And then I want to subtract 9 from both sides, so I can get rid of this 9. Once I do that, I get negative 7y is equal to negative 7. I want to get rid of this negative 7. So I have negative 7 times y, so I need to divide by negative 7 so I can get y by itself. And when I do that, I get y is equal to positive 1. All right, now again, I know what my y value is. I'm going to plug in 1 for the y here, and I'm going to solve for x. When I do that, I get x is equal to negative 3 plus 4 times 1. Well, negative 3 plus 4 is positive 1. So my system of equations, my solution here is 1, 1. All right, so the last two on here, I can do the substitution method again here, and with the the final one that's like this, you could either use the elimination method or substitution method. I found that the elimination method was a little bit easier, but I'm going to show you both methods. So I'm going to show you, on this one, I'll show you the elimination method first, and then I'll show you the substitution. But before we get to this equation, let's look at this one here. Because I have y is equal to negative 5x, I'm going to replace this y value in the top equation with negative 5x. I need to distribute the 3, and I get 3 times negative 5 gives me negative 15x. Now I need to combine like terms, so x minus 15x would just be negative 14x, because there's a 1 in front of this x. And then so I have negative 14x is equal to negative 18. I want to get rid of that negative 14, so I'm dividing by negative 14, and I get x is equal to positive 2. Now that I know that x is equal to positive 2, I'm going to replace this x with a positive 2 here. So I have y is equal to negative 5 times 2, which simplifies to 10. So my x value is 2, my y value is negative 10, and that is my solution. All right, let's look at this method with the elimination method. Notice I do not have this second equation in standard form, so I want to go ahead and put that in standard form first. And oh my gosh, I don't know why all my things go crazy. Let me see. Nope, even doing that is messed up. Oh well, pretend you don't see all this. All right, so the first thing I want to do is I want to move this 3x up front, and all I'm doing is I'm just rearranging these. So it'll be positive 3x minus 2y is equal to 12. I didn't add or subtract, I just put this term before this term. All right, so now I cannot immediately add or subtract the functions to eliminate any of my equations because neither the x variable or the y variable has the same, or excuse me, the opposite coefficient. So for opposite coefficients, if this coefficient is 2, then this coefficient should be negative 2, or with a positive negative 3 here, this should be a positive 3. So that's what I want to get. I want to eliminate one of my variables. So I've decided to multiply the top equation by positive 3 so that I can get rid of my x's, and my bottom equation I'm multiplying everything by negative 2. Okay, so for the top equation, every single term here gets multiplied by 3. So 2x times 3 is 6x, and negative 3y times 3 is negative 9y, and negative 2 times 3 is negative 6. And then on the bottom equation, I'm multiplying all three of these terms by negative 2. So 3x times negative 2 is negative 6x, and negative 2y times negative 2 is positive 4y, and positive 12 times negative 2 is negative 24. When I do that, the 6x minus 6x just cancels each other out. They're gone. Negative 9y plus 4y becomes 5y. Negative 6 minus 24, because these are both negative signs, you're going to end up adding the numbers together but keep it negative. So 6 plus 24 is 30, and that becomes a negative 30. Now to get y by itself, I want to divide both sides of the equation by negative 5, and when I do that, I get y is equal to 6. Negative 30 divided by negative 5 is the negatives cancel out. 30 over 5 is 6. Okay, now that I know that y is equal to 6, I'm going to take one of my equations and plug in 6 for y. And it doesn't matter which one I use. See, I chose the top one. So I have 2x minus 3 times 6 is equal to negative 2. I get 2x is minus 18 is equal to negative 2, because negative 3 times 6 is 18. I'm going to add 18 to both sides of the equation. And so then I get 2x is equal to 16. I'm going to divide. I want to get rid of this 2 here, so I'm dividing both sides by 2. And I get x is equal to 8. So then my x value is 8, my y value is 6, so my solution is 8, 6. All right, now same exact system of equations that I had way up here, but this time I'm going to do the solving this linear system by substitution method. In this case, I have to take one of my equations and solve for one of my variables. So in this case, I decided to take the top equation and solve for y, or excuse me, to solve for x. So I added 3y to both sides of the equation, and I got 2x is equal to 3y minus 2. I have to divide both sides by 2 to get rid of this 2. And when I simplify that, I get x is equal to 3 over 2, because 3 divided by 2 does not reduce, so that's just 3 over 2y. And then negative 2 over 2 becomes negative 1. Now that I know that this is what my x value is, I'm going to plug that equation, or this in for x, into my second equation here. So I have negative 2y plus 3 times everything that my x value equals, and then that's in parentheses, and then this equation is going to equal 12. Now I need to distribute the 3 throughout the parentheses. So I get 3 times 3 is 9, divided by 2 is still just 9 divided by 2, and then 3 times negative 1 is negative 3, and that equals 12. Now I want to go ahead and combine like terms. So negative 2y plus 9y, I can plug that into the calculator, or this becomes, I think, 4 over 2, because if I want to get a common denominator. So negative 4 over 2 plus 9 over 2 ends up with 5 over 2. Honestly, guys, it's just easier in your calculator. You would put negative 2 plus 9 over 2. Don't worry about the y's. We just want to know what is your fraction here. So those two terms here and here combine to get 5 over 2y. You still have this minus 3, so we're going to have to add 3 to both sides of the equation. When we simplify it further, we get 5 over 2 times y equals 15. Now, to get rid of your fraction, you're going to multiply everything by the reciprocal. So we have 5 over 2 here. We're multiplying by 2 over 5. You're just flipping your fraction. Okay? And notice you have to multiply the 15 by 2 over 5 as well. When you do that, this cancels out this, and 15 divided by 5 is 3. 3 times 2 is 6. So we end up with y is equal to 6. We know what our y value is, so now we can plug it into one of our equations, and it doesn't matter which one. I decided to plug it into the top equation, and I got 2x minus 3 times 6 is equal to negative 2. Simplify that, you get negative 3 times 6 gives you negative 18, plus 18 to both sides gives you 2x divided by 2, gives you 2x is equal to 20. You're going to divide. Hold on, I'm looking at that. This should not be 20, it should be 16. Okay, sorry about that, guys, which means this is 8. Let me look and make sure I did. Yeah, so up here we had an 8. Sorry, guys, there was a typo. All right, so 2x, sorry, let me go back. So negative 18, we have to add 18 to both sides. We have a negative 2 here. Plus 18 gives you 16. 16 divided by 2 is 8. So then our system is, pretend you don't see that 10. It's 8 comma 6. All right, let's look at this next one. Solve this system of inequalities by graphing. These are your two formulas. Remember, if you don't have a y variable, if it's just x is less than or equal to 2, then you're going to find the 2 on the x-axis and just draw a straight line. And this is going to be a solid line because you have the equals line here. And then you would plug in 0, 0 here for your x, and 0 is less than or equal to 2, which is a true statement. So then because 0, 0 is on this side of your pink line here, you would shade in all of this side of the equation, or of the graph, excuse me. And then for y is greater than 1, that's going to be a horizontal line right at y is 1. And notice this is a dotted line, and it's because you don't have the equal line there. And then again, you would plug in 0, 0 for y. And y, if you do y, 0 is greater than 1, that's a false statement. So then 0, 0 is right here. So you're going to shade the opposite side of where 0, 0 is. And so you're shading up here. And then, so the area that is included in the system of equations is this shaded area that is shaded with both the pink and the green. Okay. Solving this system of inequalities by graphing. Luckily, this is in slope-intercept form. So this one tells us our y-intercept is at negative 3 and our slope is positive 1. So we come down here at negative 3, we go up 1, over 1, up 1, over 1, up 1, over 1. Because we have the line here, it is going to be a solid line instead of a dashes or dots. And then we plug in 0, 0 for y. So 0 is less than or equal to negative 3. That is a true statement. Hold on. 0 is less than or equal to negative 3 is false. So because 0, 0 is here, we're going to shade in this section down here. Second equation, your y-intercept is at 2 and your slope is -1. So y-intercept is at 2 here. -1 tells us we're going down 1 to the right 1, down 1 to the right 1. And again, solid line because we have the equal sign here. And then you plug in 0, 0 for y. 0 is greater than or equal to 2, which is also false. So here's our 0, 0. Because it's false, we're going to shade in the opposite side of the green line. So we're shading over here. So the only area on this graph that is part of the solution is this tiny area right here where both the green and the pink have it shaded in. All right, I believe this is the last question, and this is going to be a bonus question on your test. You just need to solve the linear system, and it doesn't tell you which method to use. I believe I did solving by substitution. This is just one method that you could use. So I'm trying to solve for y in my top formula. And so I'm subtracting 2/3 x on both sides of the equation. I get y is equal to -2/3 x plus 14/3. So I'm going to take this whole thing right here and replace this y right here with that and into the second equation. So that's going to be really long. We have 4/5 times x minus 3/4 times everything that we had down here for our y value. And then that's supposed to equal -10. I'm going to have to distribute this -4/3 throughout the parentheses. And so when I do that, this 3 cancels out this 3. Negative cancels out the negative, and you end up with just 2/4. Well, 2/4 reduces to 1/2 x here. And then for this second term right here, again, the 3's cancel out. But this is a plus sign, and then you have a minus sign there. So you're going to end up with a minus. And then you end up with 14/4. Well, both the 14 here and the 4 here are even numbers, so both of those can be reduced by dividing by 2. So 14 divided by 2 is 7, and 4 divided by 2 is 2. And then we have that is equal to -10. You have to combine like terms, so 4/5 x plus 1/2 x. It helps if you get common denominators. If you're doing this in your head, you have to do, or on paper, you'd have to get common denominators. If you're using your calculator, you're just going to put 4/5 plus 1/2, and the calculator will give you your answer. I went ahead and got a common denominator here. 8/10x plus 5/10x is going to give you, hold on, I think that gives you a 13/10x. Yeah, so 8/10x plus 5/10x gives you 13/10 times x. Now, this -7/2, to move it to the other side, you're going to add 7/2 to both sides of the equation. And notice my -10 here, I changed it to -20/2 because I wanted to have a common denominator. So I multiply the 10 by 2, and then I put a 2 in the denominator. So that's what I did that. And that simplifies to -13/2. And then to get rid of my fraction here, I'm going to have to multiply by the reciprocal again. But I can't just multiply one side of the equation by the reciprocal. I have to multiply the other side of the equation by the reciprocal. For the first term here, the 10's cancel out, the 3's cancel out. You're just left with an x on the left side. And then over here, this 13 is canceled out by this 13. You're left with -10/2 because of this negative sign here. And -10/2 reduces to -5. So we finally figured out that x is equal to -5. And we can plug in that value to one of the equations. It doesn't matter which one. I think I chose the second one. I put -5 there. The -5 and this 5 down here cancel each other out. So you end up with -4 is equal to all that stuff. Let's see. So you get -4. So this negative does not just disappear. It has to stay with the 4. So you get negative 4. Now, we want to get y by itself, so we're going to add 4 to both sides of the equation. And when I do that, I get negative 3/4 y is equal to negative 6. To get rid of this negative 3/4, I have to multiply by the reciprocal. So I want to get rid of the negative and the 3/4, so the reciprocal would be negative 4/3. And I'm multiplying both of those terms by negative 4/3. This just cancels out to be a y. The negatives end up canceling out. The 6 divided by 3 is left, just you're left with the 2, and 2 times 4 is 8, so your y value is 8. And we found that our x value was negative 5, so this system, the solution was negative 5/8. So guys, I know this one, it was a long process to find that solution. Could you have graphed these two? Yes. Could you have done, let's see, I did substitution method. Could you have done elimination method? Yeah, probably, but substitution method is much easier than elimination method with this one. All right, so that's the end of the review. Please rewind it and watch it again if you need to, so that you are ready for the test.